Yeah, hi everyone, Mr. Markwick here. The purpose of today's video is to show you how to work out distance and midpoint of a line segment. The video is a bit of a long one, so I might mention it during the video, but maybe just go ahead and watch the first example to help you work out distance of a line segment, then go and do some questions relating to that, and then come back, watch the second example on finding midpoint and do some questions on that, etc. Anyway, before we start today, just thought I'd just go through what is a line segment. We know that a line, or a straight line anyway, is represented by a linear equation. And a line segment just goes from one set of coordinates to another set of coordinates. So it stops and starts at those given points. So this looks a little bit confusing, but if I, for example, had x values of, let's say, for example, 2 and 4, meaning that this coordinate would have an x value of 2, and this coordinate would have an x value of 4. And let's go ahead and put some y values in. We'll just make them up. So let's just say it's 3 and 6, meaning that this coordinate would have the y value of 3, giving it coordinates 2, 3, and that this point, set of coordinates, would have a y value of 6, giving this point coordinates 4, 6. So today we're actually going to work out the distance of a line segment, and these coordinates, these values, actually help us to determine the distance of that line segment. In fact, you can see there's a little bit of a triangle made here, a right angled triangle. So for distance, we're actually using a variation of Pythagoras' theorem, using the line segment as the hypotenuse. And the midpoint is basically the halfway point. That's the capital M there. The midpoint is the halfway point along that line segment, or the halfway point between those two sets of coordinates. And that's where these formulas come from. And you can see all these x2, x1, y2, y1. In both those formulas, they're taken straight from, I guess, that image there. When you look at, I'll get to an example now. When you look at a question, you won't actually see, a set of axes drawn with a line between those 2 points. It just says, find the distance between these 2 points. So I've got a set of coordinates and another set of coordinates, and I have to determine the distance of the line segment that would start here and finish here. So what I'm going to do is I'm going to substitute in to those sets of coordinates x and y, because when we look at a set of coordinates, we know that the first value is the x value and the second value is the y value. And to help me with the formula, what I'm going to do is I'm actually going to call this first set of coordinates my 1 value, so x1 and y1. That's really important that they're both 1, so the 0 and the 2, the 0 is x1, the 2 is y1, and that second set of coordinates, they're both my 2 values, so x2 and y2, and then I can go ahead and substitute those values into this formula. Okay, so this is the distance formula. As you can see, it's a variation of Pythagoras' theorem. So the distance between these 2 points, 0, 2 and 1, 7, is equal to, in fact, let's move that over, is equal to square root of, instead of x2, I'm going to use the number 1, and instead of x1, I'm going to use the number 0. All squared, that's from the formula, and then I'm going to go ahead and add y2, which is 7, take y1, which is 2. Okay, again, all squared. So now I'm going to go ahead and do what's inside the brackets there. So d equals square root of 1 take 0, which is 1, all squared, plus 7 take 2, which is 5, all squared. Now I'm going to go ahead and square those values underneath the square root sign there. So d equals the square root of 1 squared, which is 1, and 5 squared, which is 25. So d equals square root of 1 plus 25, or the square root of 26. Now, because 26 isn't a square number, I'm going to leave that in exact form, or surd form. Okay, it's asking for exact distance, so leave it as a surd, square root of 26. If it was a square number under there, for example, 4 or 9 or 81, then I could actually get an exact value, but in this case I'm going to leave it as a surd. Okay, second example is pretty much the same process, except there's some negative values in here, so it's a little bit trickier, but essentially we're doing the same thing. We're giving those sets of coordinates values. Let's just go ahead and use red. So I've got x1 and y1, and x2 and y2. So the first set of coordinates are my 1 values, x being the first number in that set of coordinates, y being the second, and my other set of coordinates, my other point, is my 2 values. Go ahead and substitute those into the distance formula. So d equals square root of x2, I've got 4, take, okay, keep the take sign from the equation, from the formula, take x1, which is -1, so -3, my apologies. So now we've got 4 take -3, we'll get to that in a minute. Let's do the rest of the formula. We've got y2, which is -1, take y1, which is 8. Now again, I'm going to go ahead and just do what's inside the brackets there. So d equals square root of, now 4 take -3, 2 negative signs next to each other like that would then cancel out and give us a positive. So it becomes 4 plus 3, which is 7. And then I've got -1 take 8, which is -9. Again, all squared. Now I'm going to go ahead and square those values. So d equals the square root of 7 squared, which is fine. 7 times 7 is 49. And then I've got -9 squared. Remember, when you're squaring a number, you're timesing it by itself. So -9 squared is the same as -9 times -9. And a minus times by a minus is equal to a positive. So that's positive 81. So square root of 49 plus 81. So the distance of that line segment is equal to square root of 130. Again, 130 is not a square number, so I'm going to leave it as the exact value, square root of 130. All right, and that's it. That's how you work out distance of a line segment, or distance between 2 points. Again, they'll just give you 2 sets of coordinates. Label those first set of coordinates as your 1 values, the second set of coordinates as your 2 values, and make sure you substitute them correctly into that formula. The biggest mistake people tend to make is they put the wrong number in the wrong spot. But if you label them correctly to begin with, it should be fine. Okay, so my guys, questions to this example will help you with from the textbook today on page 45 is question 4. Okay, so if you go ahead and have you got some of those questions, 20 or 25 minutes, once you got your head around some of those, then come back to the video here and have a look at this next example where I'm going to show you how to work out the midpoint of a line segment. And the midpoint is actually going to be, if we go back to this diagram we started with, the midpoint is going to be an actual point on that line. Okay, so it is going to be a set of coordinates. Okay, so what we're actually doing is we're working out the average of my 2 x values and the average of my 2 y values to give me a halfway point, which is why in the formula we're dividing by 2. We're adding the 2 x values, dividing by 2, and writing the 2 y values and dividing by 2. We're working out the average of the x values and the average of the y values, and that's my midpoint. So again, you'll get 2 sets of coordinates. Just label those again, x1, y1, x2, and y2, and just substitute those values again into the formula. So m, in this case, is a different formula, but m equals, instead of x1, be careful, I've got -3, plus, instead of x2, I have 2, it's divided by 2, and the comma, y2, oh, sorry, it could be, I'll put a y2, y1, doesn't matter, we're still adding them together. Let's do 8 plus -5 over 2. The actual formula, guys, is actually y1 plus y2. But again, it doesn't matter because you're just adding those 2 numbers together anyway, so we'll still get the right answer. So if you see in the textbook, it is y1 plus y2. My bad. Not worthy of restarting the video, that's for sure. Anyway, now I'll just go ahead and add those two values on each of the numerators. So m equals minus 3 plus 2, which is minus 1, over 2, and 8 plus negative 5, that becomes 8 take 5, which is 3, again over 2. And that's it. That could be a set of coordinates, minus a half and 3 over 2. Algebraically, we tend to leave those points or set of coordinates as fractions. If you were actually to go ahead and try and draw it on a set of axes or a Cartesian plane, you might want to convert it to a decimal. But for the sake of this, and if you're looking, my class, if you're looking in the back of the book to check your answers, they will be in that fraction form. Okay, so my guys, if you wanted to use that example to help you with question 5, which is essentially just question 4, but you're working out the midpoint. So you use those coordinates from question 4, but you just use the formula, the midpoint, to work out the midpoint between those 2 points, if that makes sense. I think you get the point. Anyway, the final example I'm going to go through is how to use a value to find a set of coordinates. So we actually have a distance here, which is square root of 5 between these 2 points. The only thing we're missing is one of the y values there. Again, you just go ahead and label those values. So let's go ahead and say this is my x1, my y1, my x2, my y2, and this is my distance. And then go ahead and substitute those values into this formula. So the distance, which is the square root of 5, is equal to square root of, instead of x2, I have 4. Instead of x1, I have 2. So 4, take 2, all squared. Plus, instead of y2, I have 9. And instead of y1, I have the value a. So just pop in a, again, all squared. Now, it's a little bit trickier, but I'm going to go ahead and just do this bracket that I do have the information for. So I'm going to do 4 take 2 all squared. So square root of 5 is equal to square root of 2 squared plus 9 minus a all squared. I know that 2 squared is 4, so I can go ahead and do that. Square root of 5 equals square root of 4 plus 9 take a squared. Now this is a little bit trickier. We're going to have to solve this algebraically for a. From this point onwards, I've actually got a square root on both sides of the equal sign. So to get rid of that, I can square both sides of my equation. I'm keeping it balanced still. Square both sides. I get rid of those square root signs. I've got 5 equals 4 plus 9 minus a all squared. Alright, getting a little bit trickier now, but bear with me. I'm going to get rid of the 4 from the right-hand side of this equation. So take 4 from the right-hand side, which means I need to take 4 from the left-hand side. Leaves me with 5 take 4 equals 1, and that's equal to 9 take a all squared. Sorry, I changed the red pen. Alright, at this point, I kind of need to explain a little bit. So I have to get rid of the square from this right hand side. I can just find the square root, I guess, of that side, which means I need to find the square root of 1 over here. So this is a little bit complicated, but the square root of 1 is positive or negative 1. Okay, and this is probably not a good example because I've got 1 here. But think of it this way: the square root of 4 could be equal to 2. 2 times 2. The square root of 4 could also be equal to negative 2. Okay, negative 2 times by negative 2, or negative 2 squared, is also 4. So at this point, my answer could be one of 2 possibilities. So 1, positive 1, might be equal to 9 take a, or negative 1 could be equal to 9 take a. Alright, so now to solve that further algebraically, I'm going to get rid of the 9 from the right hand side. So to get rid of that positive 9, I'm going to take 9, sorry, I'm switching to blue pen here. Take 9 over here. 1, take 9 is minus 8 equals minus a. And if I divide both sides by minus 1, then I'm left with 8 equals a, or a equals 8. And over here, I'm going to do the same thing. Alright, so to get rid of the 9 from the right hand side, I'm going to take 9. Again, I need to do that from both sides. So minus 1, take 9 is minus 10. Minus 10 is equal to minus a. Cancelling those negative signs out, I'm left with 10 equals a, or a equals 10. You may think, why do I have two solutions, right? So the distance, square root of 5, between those 2 points could be, a could be equal to 8, or it could be equal to 10. And this sort of explains it a little bit better if I can actually just show you. So we know that this was one of the points, 4, 9, and we know that the distance of the line segment was the square root of 5. So the square root of 5 can be the distance between this coordinates, or these coordinates, 4, 9, and 2, 8, the value we worked out. Or, same distance could be between that set of coordinates, 4, 9, and 2, 10, which we worked out. The distance is still the same. Okay, so that sort of, I guess, explains it a little bit more visually. And yeah, a little bit hard to get your head around because we sort of haven't looked at that before. But you understand, I guess when you get to this point, you could have one of two possible answers. And again, I didn't really like this answer because the square root of 1 is 1 or negative 1. So it's better when you have a different value like 4 or 9 or 16 or something. Anyway, hopefully that process helps, guys. And that, for my guys anyway, will help you with the following question in your textbook, which is question 8. Okay, so like I said, a long video. Thanks for sticking it out with me and watching. And hopefully that helps.